Dear student, in this session, we will discuss the subtopic 3.4 Threads from Unit number 3 Process Management. The course outcome for this session is you will able to execute the process commands for performing the process management operations, and the learning outcome is you will able to explain the function carried out in the given process step. In this session, we will discuss the details related to the threads, its benefits, the user and kernel threads, and the multi-threading models. So let us discuss with the thread. A thread, it is also called as a lightweight process, is nothing but a basic unit of CPU utilization. It consists of a thread ID, a program counter, a register set, and a stack. Generally, a thread shares its code section, data section, and other operating system resources such as the open files and the signals. A traditional or heavyweight process has a single thread of control. If a process has multiple threads of control, it can perform more than one task at a time. One of the example is a word processor may have a thread for displaying the graphics. Another thread may read the keystroke from the user, or another thread may perform the spell and grammar check onto the background. So here we have the diagrammatic representation of a single threaded process and the multi-threaded process. In a single threaded process, we have a single thread having its own register stacks, data, code and files, whereas in the multi-threaded process we can see that every individual thread has its own register and stack over here, and the code, data and the file section, this is shared by all the threads. Some of the benefits of the multi-threaded system is the first, responsiveness, that means the multi-threading and interactive application may allow a program to continue its running even if the part of it is blocked or perform a lengthy operation. That means, say for example, a multi-threaded web browser still allow the user interaction in one thread while an image is being loaded into another thread. So it is continuously responding to every individual thread in the multi-threaded environment. Another benefit is resource sharing. We know by default the threads share the memory and the resources. Thus, sharing the code and the data allow an application to have several different threads of activity within the same address space. So that's why it is helpful for sharing the resources. Third benefit is it allocating the memory and resources for process creation is costly. But when the thread shares the resources, hence it is more economical to create and context switch the threads. So the cost will be automatically reduced when the resources are shared in between the processes. Fourth benefit related to the multi-threaded architecture is utilization of multiprocessor architecture. So multi-threading, it can increase in multiprocessor architecture where threads may be running in parallel on different processes. So due to this, it increases the concurrency of the system. Now let us discuss about the user thread. So threads that are implemented at the user level are known as user threads. Thread management related to user done by the user level thread library. User threads are supported above the kernel and managed without the support of kernel. Some of the primary thread libraries related to users are O6P thread, Win32 thread and Java threads. Now, the kernel threads. So, the threads that are implemented at kernel level are known as kernel threads. Kernel threads are supported and managed directly by the operating system, and some of the operating system which supports the kernel threads are Windows XP 2000 and NT, Solaris, Linux, 264 Unix and Mac OS X. These are the operating system which supports the kernel thread. Now let us discuss the multi-threading model. So basically three modules are there related to multi-threading: many-to-one, one-to-one and many-to-many. Let us discuss in detail the many-to-one model. In many-to-one model, many user threads are mapped with a single kernel thread. So here the thread management is done by thread library in user space. So whatever the threads that we have to manage, that are managed in the user space, and hence the management due to this it is efficient. Then and one of the drawback related to this many-to-one model is that whenever there is the process executes the blocking system call, then the entire process blocked. So due to this we will not able to execute another processes. Another disadvantage we can say that the multiple threads are unable to run in parallel on the multiprocessor, since we have a single kernel thread running at the same time. Some of the examples of many-to-one models are Solaris Green Threads and the GNU Portable Threads. Another multi-threading model is one-to-one model. Now, in this particular model, we can see that each user level thread maps to the kernel level thread. It allows another thread to run even when the blocking system call is executed with any one of the threads. So whatever the drawback we have seen in the previous, that is many-to-one, that particular drawback is removed over here in one-to-one. Then it also allows multiple threads to run in parallel on multiprocessor. So this is also the drawback we have seen in many-to-one model, which is removed over here. Since we have a one-to-one user to kernel thread, multiple threads can parallelly run on multiprocessor. Now the drawback related to one-to-one is that creating the user thread, every time we require to create the corresponding kernel thread, right? So due to this, what happened? There is the overhead of creating kernel thread, and this burdens the performance of the application. So this is what the drawback related to one-to-one. Some of the examples related to one-to-one are Windows 95, 98, NT, XP and 2000. These are some of the systems in which the one-to-one model is used, and the Linux. Another variation of multi-threading model is many-to-many model. So in many-to-many model, it allows many user level threads to map to a smaller or equal number of kernel threads. Here, the developer can create as many user threads as needed, and corresponding kernel threads can run in parallel onto the multi-processor system. Whenever the thread performs any sort of blocking system call, the kernel can schedule another thread for execution. That means it will not stop the execution of processes continues. Examples are Solaris prior to the version 9 and Windows NT and 2000 with a thread fiber package. So these are the examples related to many-to-many model. One variation to many-to-many model is also available, and that is two-level model. It is same as that of many-to-many model, except that it allows a user thread, here we can say user thread, be bound to the kernel thread. So this is what the variation, and due to this variation, this is also referred to as a two-level model. Some of the examples of these are IRIX, HPUX, 264 Unix, and Solaris 8 and earlier. So this is all about the different multi-threading model related to system. So here in this session we discuss details of the threads, the benefits of multi-threaded, user and kernel thread, and the multi-threading model, that is the many-to-one, one-to-one, and many-to-many. The book refer is Operating System Concept by Galvin Cagney. Thank you.